So you might be thinking to your middle school math, right? Like, that's so easy. Why are we learning this in geometry? We already learned that. But I promise to make it geometry level, and I promise that we'll make it K level. So let's remind ourselves of what the formulas are for area and perimeter of a rectangle and a square. So how do you find the perimeter of a rectangle? Very nice. You double the length, you double the width, and you add them together. And that comes perfectly from last unit, because in last unit, we learned in a parallelogram, opposite sides are congruent. So the length equals the length, and the width equals the width, or vice versa. Usually the length is considered the longer side, and the width is considered the shorter side. Or Abby says you just add W plus W plus L plus L. But yeah, the simplified version of that would be 2L plus 2W. What about the perimeter of a square? Good, Johan, that's exactly what I have. 4S. So we're going to call the side of a square S. S for side, I guess. They're all congruent, all four sides, and so you just quadruple the length of one of the sides. Easy. All right, what about area? The area of a rectangle. So we're not going to be adding this time. We're going to be multiplying. Good. So, width times height, base times height. So the traditional one is length times width, but you may also use base times height. It just depends on how you're going to name the sides, okay? Ganesh, you're writing these down on this thing. That's where you're going to keep your formulas. We'll add to it each day. Right, Abby, right. So you can consider the area length times width, that's what the L and W are, or base times height. Area of a square, side squared. But if you want to consider the area of a square, base times height, you can, because you know that a square is a rectangle. So you can use either one, okay? Yep. All right, let's just dive right in. Let's just practice things. You use your formulas and you solve the problems. That's what this unit's going to be all about. You're already answering. Okay. So in this one, you have two choices. You could just work with a diagram, especially if you're a visual learner, or you could work with the formula, okay? So you could work with the formula, 2 times the width plus 2 times the length equals 20. And you could solve. 8 plus 2L equals 20. 2L equals 12. L equals 6. Or you could do like the common sense way, and you could be like, oh, well, if that's 4, then that's 4. Okay, I've used up 8. 20 minus 8, that's 12. I need to split it evenly between the top and the bottom. So split it evenly, 6 and 6. You're doing the same process either way. One way you're just documenting each step, and the other way you're just using common sense in the picture, okay? And then the area, very good. How do you find area of a rectangle? Length times width or base times height, whichever way you put it. You're going to get 24 feet squared. So notice what I did on the units there. The length is 1D, so that's feet. The area is two-dimensional, 2D, so I put feet squared, okay? Now, what I see students do every now and then, and what you would never, ever, 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 ever do, is area equals that. Did it come up on your screen yet? Mine has a lag. There we go. You would never put that the area is 24 squared. Sometimes when I don't give you units, people square the 24 instead of squaring the units. So that would be absolutely wrong. I would have to count that wrong on your paper. It's 24, and then you put the units squared. You square the units, you never square the actual value. You never square the numbers, so be careful about that. Okay. Next one, find the perimeter and area of the rectangle. Round to the nearest whole number. Now, I promised you I would take this from middle school math to high school math, and we're totally doing that in this problem right here. I'm going to give you some time to think about it. I will give you a one-word hint. What's my one-word hint? Trig. Oh, Karthik said sine, but I'm saying trig. You're going to have to use trigonometry. Oh my gosh, it's been a while. So, I will remind you how to spell SOHCAHTOA. To find the perimeter in the area, you need the length and the width. There's no way around it. You need those values. So you can call this W. You can call this L. How do we find W? Exactly what y'all said. We would do sine. Opposite over hypotenuse. And then how would we find the length? We would do cosine. Adjacent over hypotenuse. Make sure, we haven't done this in a while, make sure your calculator is in degree mode. Go to the mode and make sure it's in degree mode. Okay, thank you, Victor. You thought we were done with trig. You're going to keep using trig in your next maths to come. Ooh. Now, remember, we love our answers to be as exact as possible. So I'm not going to round as I go. I'm going to round at the very end. So in my calculator, I'm going to make sure it's in degree mode. Yep. Then I'm going to do 33 sine 28. And I get a decimal. Okay. If you want to, you can put you can just keep many, many decimal places, or you can just store it in your calculator. Now I'm going to find the other one, 33 cosine 28. About that. And now to find the perimeter, we're just going to double each one and add them together. So times 2 plus what does it say to round to? It says to round to the nearest whole number. So actually, we might not have needed to keep that many decimal places. When you round it, you get, what y'all get? 89. The perimeter is 89. We don't have units here, so it's not necessary to put units. All right, now let's do the area. We're just going to multiply these together. Voila, what'd you get? 451 square units. But like I said, we're not going to put the units because we don't have units. All right, let's keep moving on. Find the perimeter and area of the square. Since it doesn't specify to round, it wants our answers to be exact. Anytime it doesn't give you rounding instructions, it wants you to be exact. How are we going to find the sides of the square? So we're having to remember properties about quadrilaterals, right, from last unit. We know that in a square, when you draw the diagonal, we know that this is a 45, 45, 90 triangle. And we know that the rule is x root 2. But what happens when x root 2 is an integer? How do you undo multiplying by root 2? You have to divide by root 2, right? So to go from here to here, we have to divide by root 2. So 8 divided by root 2, then we rationalize. Remember, there is a shortcut, and we talked about this when we were in this unit. It's always, the legs are always half of the hypotenuse root 2, when your hypotenuse is an integer. Okay? Good. So the side is 4 root 2. You were correct. So we multiply that by 4. And the perimeter is 16 root 2 meters. What's the area? Some of us are still struggling with squaring radicals. 4 root 2 side squared. So you do 4 squared and you get 16. And then you do square root of 2 squared and you get 2. So the area is 32 meters squared. Good. So we don't need to do any decimals because we're going to be exact unless they tell us. This one will take you a little time because you need to draw this on your paper and find the missing sides, or maybe you don't, but I'll give you a few minutes to look at this one. So what's the strategy when doing a problem like this? The biggest thing that you need to remember is that you should only look at values horizontally first. Look at everything that goes horizontal and ignore the other numbers, and then look at everything that goes vertically and ignore the other numbers, okay? Let's do vertically first because I know that one's easier. So look at everything that's vertical. 18, 5, and 8. So when we're finding the missing side, we're going to ignore the 9 and the 20. Don't look at those. Look at everything going vertically. Well, if I have 18 units and I've used up 5 and I've used up 8, how many do I have left? That's going to give us this value right here. So it's like segment addition. Part plus part equals whole. 8 plus something plus 5 equals 18. So we know that that missing side is 5. Now, in this problem, the horizontal one is a little bit tougher. Let's go horizontal now. We know that the whole is 20. We know that this is 18 because it has a tick mark. Tick mark, tick mark. And then we also know that this one's 9. So we're looking at all of our horizontal ones, but there's some overlap. So we kind of run into trouble because of the overlap. What I would do is I would look at this overhang right here. How far is it from there to there? Well, we've got 20 minus 18. Do you see where the 20 goes and where the 18 goes? That means this is 2. Well, if that is 2, then I can do 9 minus 2 to find that missing side that I needed. 9 minus 2 is 7. And now I know all of the sides of my figure. So finding the perimeter is easy. We're just going to add them up. What did you get for the perimeter? Add up all those sides, don't miss any, and you get 108. And then to find the area, you would just break this up into rectangles. You can break it up however you want. You break it up by drawing segments, okay? So we could break it up, there's lots of different ways. I could do this one here, and then I could do, I'll just go this way. I'll just keep it simple. All right, so then what I do is I write the area inside each rectangle. 18 times 5. So the area of this one is 90. Okay, what's the next one? Uh-oh, that's 5 by, let's see, 20 minus 9 makes this 11, because 11 plus 9 is 20. So the area of this one is 55. And the area of that bottom one, length times width, 20 times 8, 160. So once you find the area of each rectangle, you can just add them up for a total of 305. Oh, we got the perimeter wrong. Thank you for correcting it, Rishi. You got a little happy you added too many things together, huh? Too many 18s? Okay, sorry. Correction to the problem. Correction to the problem. The perimeter is 90 and the area is 305. Good. You added one too many 18s. That's cute. Okay. Find the length and the perimeter of the rectangle. Go. Okay, how do you find the area of a rectangle? It's length times width. So be careful when you multiply these together. You need to make sure that you FOIL. This is going to be x squared. Well, you get lucky on this one, don't you? X squared minus 2x plus 2x minus 4. These will cancel, which is kind of nice. And so we know that 60, the area, equals x squared minus 4. So we're going to add 4 to both sides. 64 equals x squared. X is plus or minus 8. So what is the length? 8 plus 2. We would not use the negative answer that we got because it wouldn't make sense. We can't have a negative length. Okay? The perimeter would be, let's see, so this is 10 and this is 6, right? 32? Very good. Once again, we don't have units, so we don't need to worry about that. 10 plus 10 plus 6 plus 6. Or 10 times 2 plus 6 times 2. Whoa. Try that one. All right, so we need to find the area of the shaded region. Those regions are just rectangles, right? They're not that scary. It's just 4 rectangles and we have 2 pairs of congruent rectangles. So we just need to find the length and the width. So I know that this is 10 and this is 10. So I know that right there we have, what, 36? That means this is 36. So now I can do Pythagorean theorem to find the length. 85 squared minus 36 squared, and take the square root. And yes, I made it a whole number again. I love finding new Pythagorean triples that I've never seen before. So 36, 77, 85 is a Pythagorean triple. Who knew? So that is 77. What do we want to do from there? I think we pretty much got it, right? 77 times 10. This is 10. So 770 is the area of that one. 770 is the area of that one. 36 by 10. 360 is the area of that one. And 360 is the area of that one. So add them all up. Nice. 2,260. Do we all agree? Those numbers are kind of hard to see that I wrote there. 770 are the 2 long rectangles, and then 360 are the 2 short ones. What questions do y'all have? So here's our last problem. They're not weird, they're unique. So we had a problem that had trig. We had a problem that used Pythagorean theorem. We had a problem that had 45, 45, 90. So here's your problem with your 30, 60, 90. So make sure to use your 30, 60, 90 rules on this one to find the missing sides. You want to find the area of the shaded region. So you could find the area of each triangle and add them up, although we haven't learned triangles. So what I would do is I would find the area of the pink rectangle, the large one, minus the area of the white rectangle. That's the route I would choose. The area of the whole minus the area of the inside. So we've got our 30 here. Unfortunately, bad news, the 12 is across from 60. So that's bad news because here's our 30, 60, 90 rules, and the 12 goes here. That's sad face, but we can still deal with it. We need to divide by root 3 to get our missing sides. So we know that this side is 4 root 3. All right, let's look over here. If this is a rectangle, then this is 90. So if that's 30, then this guy's 60 right here. Thank goodness on this one, the 2, on this one, the 2 is across from 30. So that's nice for us to find our missing sides there. So this is 4, and this is 2 root 3. This is 4 root 3 from the other side. And across from 90 on this one, I didn't finish this out. This is 4 root 3, so we double it, and we get 8 root 3. So this is 8 root 3. So now let's find the area of the pink rectangle. Let's see, the length is 12 plus 2. The length is 14, and the width is 6 root 3, because it's 4 root 3 plus 2 root 3. Okay, next one, the area of the white rectangle would be length times width, either way. Oh good, everything has a root 3 in it, so we're going to be allowed to subtract these. 14 times 6, 84 root 3, 4 times 8, subtract those, are we okay with our answer?